Hello code champs, number ninjas, and data divers. Today we're looking at a new feature of the Clojure editors Cursive and Calva called flares. Flares are signals to the editor that you want something to happen. So here's a bit of code in a Cursive project following the literate programming style. So literate programming is when we interleave code, narrative, and visualizations. We're literating right now, in fact. So if I want to render this file, I can run the clay make file REPL command. And you can see it rendered the namespace as a HTML document. So the markdown got marked up to HTML, and it still displays code and the results of evaluating the code. And also it allows us to take some data and visualize it in a table. Or we might want to look at it as a chart. I'm just going to move this over to the right here now so I can have my code and the visualization side by side. Because I want to show you, if you want to just work on one little part of the code, make top level form. There we go. And you can see that we created this little SVG of a circle. And that's kind of nice if you want to, be editing this, changing it, and then you want to just quickly look at it and see how it looks. Anyhow, the main point I want to make here is that my code doesn't contain any rendering code at all. Clay is a tool, and it's just seeing the metadata annotations, and it's just rendering it accordingly. It's kind of nice because my code compiles without any external tools, and people are free to experience the code however they please. Like they might want to try it in a REPL, they might prefer reading it as this HTML maybe on a website, or they might explore the visualizations with their own choice of tools. They might use a browser, and they might use a different editor. Speaking of which, how are we seeing this in our editor? Well, this is where we get into flares. Flares is this new feature of both Cursive and Calva, and we're going to send our first flare manually from the REPL. So I'm just going to evaluate this little window opened here. Flares are special values that request IDE behavior like showing HTML. Flares enable tools like Clay to show data visualizations, but you can also make your own custom REPL commands that produce flares. We can open a URL instead of passing in raw HTML. And so you can see we can browse the Clojure homepage. Cursive has a display editor option, and this will open it in a separate panel like we saw with Clay. I'll just put this over here for now. You'll also note this key. Specifying a key identifies a panel to reuse, so we don't continually open up a new panel. So now if we open a different URL, it'll just replace the existing view. Obviously, the URL can be localhost if you're doing development, like working on an app or something. In this case, I have Clay running on localhost. So if we look there, we see the Clay that I was previously working on. The default view for Cursive is inline, and the default view for Calva is editor because inline is not supported. So these examples were just to demonstrate how flares work. You wouldn't actually go putting these throughout your code base. Generally, you'd want your flares to be produced by tools. And so right now we're going to make our own little tool. I'm going to call it a hammer. And what it does is it just takes some hiccup, renders it to HTML, and then returns a tag literal. So let's just evaluate this, and then we'll try out our new tool, hammer, on some hiccup. And as you can see, it rendered it to HTML. Great. So that's kind of all that Clay does, with a few more bells and whistles. We can move this into a custom REPL command, and then it's going to be really great. So then it'll be just like in Clay, like how we have these, these make commands available to us. And the way you do that is you just define a new custom REPL command, and then usually you'd say, well, I want to insert the top level form into my usage of the tool. So great, we've successfully moved the behavior, the rendering, and also the mechanism, which is the flare, out of our code and into a tool. Let's take a closer look at Clay's REPL commands. So in Clay, this is a namespace which generates all those commands that we saw. And they've all got a very similar kind of set of settings. The most important one is that we want to show the inline results if we get any. Then there's just a snippet. So this snippet of code calls into Clay. Clay happens to have a namespace called snippets, which is dedicated to making these commands available. Custom REPL commands are just calling this code and then inserting the appropriate thing, like whether it's a form or whether it's just operating on the file path. As you can see, we're just mapping actions that we want to take to code that we want to execute, and the code that we execute is going to return a flare. Okay, let's take a little bit of a tangent to talk about tagged literals specifically. You probably noticed I glanced over the fact that flares happen to be tagged literals, and that's because it's not really important. Any special value could have been used as the convention, but let's take this opportunity to explore exactly what is a tagged literal. So behold, this is our first look at a tagged literal. It is a string, but it's got this little tag in front of it. So the tag is the hash inst part, and the value is the string. And any white space is optional, so you can have it or not, depending on your preference. And when Clojure reads this in, it's going to convert the string into a date. And so it's a very convenient way to serialize and deserialize. If you look here, the type of this is actually a Java date object. So it's converted it to a date from a string. It just so happens that you can provide your own tagged literal readers, and they can perform arbitrary transformations. So here I'm going to do something wild and crazy. I'm going to define an infix tag, and it's going to do a transformation that you might expect. And as you can see, when we evaluate that, evaluated 2 plus 3 and got the answer 5, which is totally exciting if you like infix. More realistically, this is usually used for serializing and deserializing custom records, but I'm not going to go into that. What I do want to look at is if you construct a tagged literal, you get the actual object tagged literal. So this is different from the interpretation of the tagged literal, which was a date. This is a tagged literal data object. And we can construct any kind of tagged literal we want without needing any readers. For example, I can create this tagged literal here that's my tag, and it's attached to a map. And as you can see, we created a tagged literal, and it prints it in this funny syntax just to indicate that it is a tagged literal. Tagged literals allow extension of the Clojure syntax and Eden syntax with domain-specific types. And these extensions are called data readers. So you can also set the default handler to something, and you can set the default handler to be the tagged literal constructor function itself. And what this means is that if Clojure tries to read any literal tagged literal, it will just return a tagged literal instead of doing the normal dispatch if there's no dispatch associated with this symbol. So the way you can see that is right here. We have this custom mysim and my data, and now because we set the default data reader to tagged literal, it reads it in as a tagged literal. Because of that, it means that you can write flares like this. I don't recommend it for the same reason I don't recommend defining an infix reader. I think it will make your life confusing. I don't recommend it. I don't recommend defining an infix reader either. This was just an explanation of what tagged literals are. So too long didn't read is tag literals are a Clojure feature. You can read more about them on the Clojure website. Flares happen to be tagged literals, but that's not super important. The only thing that's important is that they are recognizable as a request for action. And likely you only need to make flares from within tooling helpers themselves. Some final thoughts. I think it's great. Clojure tools can now be that little bit more integrated. The results can be shown as HTML right there inside the IDE. And that feels really nice for visualization tools like Clay. Similar experiences are definitely possible for other libraries like Mali, Spec, Portal, Condo, Hyperfiddle, and Flowstorm. And so if you're interested in collaborating on that, a really good place to start is taking a look at the Calva Power Tools extension. It's a contributor-friendly place to add shareable tooling commands and default key bindings. Until next time, keep coding.